Welcome to the lesson, Types of Fuel Cells, Advantages and Disadvantages. In this lesson, we will discuss how different types of fuel cells compare to one another, given their advantages and disadvantages. Let's look at our lesson objectives. By the end of this lesson, you will be able to identify the advantages of the different types of fuel cells. Next, you will be able to identify the disadvantages of the different types of fuel cells. Finally, you will be able to explain why different fuel cells are used for different applications. We will begin by comparing the advantages and disadvantages of the different types of fuel cells to understand their strengths and limitations. Let's start with molten carbonate fuel cells. They are highly efficient and can utilize various types of fuel, making them suitable for steady power generation. However, they operate at very high temperatures, take a long time to start, and face corrosion and material challenges, which limit their applications. Now let's look at solid oxide fuel cells. They are highly efficient and use a solid electrolyte. They can operate using hydrogen or carbon monoxide as fuel. Because they operate at very high temperatures and start slowly, they are better suited for stationary applications rather than quick start systems. Next, we will look at alkaline fuel cells. They operate at low temperatures and produce a high cell voltage. These advantages make them efficient, but they are very sensitive to carbon dioxide and require pure hydrogen. This limits their use of controlled environments. Continuing with the advantages and disadvantages of the different types of fuel cells, we will now look at phosphoric acid fuel cells. They are stable and can tolerate fuel impurities, which makes them reliable for long-term operation. They are bulky and less efficient than high-temperature fuel cells, so they are mainly used where steady power and heat recovery are needed. Next, let's look at proton exchange membrane fuel cells. They operate at low temperatures, start quickly, and are compact in design. These features make them well suited for vehicles and mobile applications. Their primary limitations are the requirement for pure hydrogen and the utilization of expensive materials. Finally, we will look at the advantages and disadvantages of direct methanol PEM fuel cells. They use liquid methanol instead of hydrogen gas, which simplifies fuel storage and handling. However, they produce less electrical energy and release carbon dioxide, making them better suited for small or portable power applications rather than vehicles. Why are different fuel cells used for different applications? The reason is that they are designed to work in different ways. Operating temperature affects both the rate at which a fuel cell can start and the amount of heat it produces. Fuel type and electrolyte design also affect efficiency, durability, and system size. Engineers select a fuel cell based on its intended use and application. Let's look at the summary for our lesson, Types of Fuel Cells, Advantages and Disadvantages. We compare the advantages and disadvantages of different types of fuel cells to understand why each is used in specific applications. Molten carbonate fuel cells are highly efficient and can operate using various types of fuel, making them well suited for steady, large-scale power generation. However, their extremely high operating temperatures, long startup times, and material corrosion challenges limit their applications. Solid oxide fuel cells also operate at very high temperatures and deliver high efficiency using a solid electrolyte. They can run on hydrogen or carbon monoxide, but because they start slowly and generate significant heat, they're mainly used in stationary power systems rather than applications that require quick startup. Alkaline fuel cells operate at significantly lower temperatures and produce a high cell voltage, making them highly efficient. However, they are highly sensitive to carbon dioxide and require pure hydrogen, restricting their use to controlled environments. Phosphoric acid fuel cells are renowned for their stability and ability to tolerate fuel impurities, making them a reliable choice for long-term operation. Their larger size and lower efficiency compared to high-temperature fuel cells mean they are typically used where steady power and heat recovery are important. Proton exchange membrane fuel cells operate at low temperatures, start quickly, and have a compact design. These characteristics make them ideal for vehicles and other mobile applications, although they require pure hydrogen and rely on expensive materials. Direct methanol PEM fuel cells utilize liquid methanol instead of hydrogen gas, thereby simplifying fuel storage and handling. However, they generate less electrical energy and release carbon dioxide, making them more suitable for small or portable power applications rather than vehicles. Different fuel cells are used for different applications because they are designed to operate under different conditions. Factors such as operating temperature, fuel type, electrolyte design, efficiency, durability, and system size all influence the selection of a fuel cell. Engineers choose the fuel cell that best matches the performance requirements of the intended application. Thank you.